Hello everyone, in this video I'll be explaining you about the New Year chaos problem inside the array subsection in interview preparation kit of HakerRank. So if you must have gone through this problem, you will be knowing that in this problem we'll be provided with the following input set in which the first input depicts the number of test cases, the following subsequent test cases. In the first number depicts the size of the input array, and the subsequent elements depict the elements of that input array. What we need to return is a value or two chaotic. A value is to be returned when a number has not swapped with its previous adjacent numbers. More than two numbers are not being swapped. At that time we need to return the number of swaps that has taken place. And if that is not the case, if an element has swapped more than two positions, that is 3, 4, 5 or beyond that, then we need to return 2 chaotic as the answer. So as you can see over there here, a clear depiction of the first case, that is 2, 1, 5, 3, 4, is somewhat like this, that the element 5 must have bribed first 4 and then bribed 3 in order to reach the position 3. And similarly 2 must have bribed the 1 to reach the position of 1. And hence this 2, 1, 5, 3, 4 is the input that we have got. To get it back to the position, we have to analyze that how we need to get this back to that 5 back to its position and 2 back to its position, and hence also count at the same time count the number of swaps that has taken place. In this case that is 3, and if anyway, as you can see in the second way, that is second input, that is 2, 5, 1, 3, 4, 5 has reached the second position out of nowhere. That is 5 was in the 5th position and it has reached the second position, which is swaps beyond 2 indices. So definitely we are going to return 2 chaotic as the answer. So there would be probably multiple approaches to solve this problem, and it's quite obvious that most of them would go with the approach of running 2 loops. One probably the first loop would be iterating through the entire elements, and the second loop will basically check if that element is not in the right position where it is, but that solution can probably have a complexity of at about around O of n square, which would not be optimal. So the solution that I would be using over here is my approach, and let's see what would be the complexity over here. As far as my knowledge, the complexity is going to be order of n. So yes, it would definitely be optimal than the previous solution that I had suggested. So let's directly, as this problem is not that quite hard, let's directly go by the code. Before that, this is to bring to your notice that the numbers that I have mentioned over here with the blue color is basically the index positions, and of course the other one is the position of the person where is standing. And here a loop variable will basically be this position and not the index, so we have to do some compensation with the index. And regarding loop variable, whether we need to take the position as the loop variable or the index as the loop variable, and how the compensation is done, you can just look on to my previous video that I had uploaded, that is minimum swaps 2. If you have not looked it out yet, please have a look for that video as well. Also you will find the link card above, which you can just click to reach that video. Coming back to this video, we'll be starting with initializing basically this is a function that has been provided by HakerRank, that is minimumBribes, and we got the input array as the input through the argument. The first primary thing that we are going to do is to make the bribes variable initialized to 0, and that is the variable in which we are going to store the number of bribes that has taken place. And we will be also using a flag which has been initialized to 0, and later on at a stage we'll be changing it to 1 if there is any case in which we find out that a person has swapped more than 2 positions. and we'll be starting at the same time of explaining this code. I would be depicting the same with the illustration that that I have provided in the left. So we'll be starting with the loop variable I, which has been given a value of q dot size, that is in this case it will be 5. So now I is pointing to 5, and hence it will go up till only till 1, and that's the reason I told you before that we'll here a loop variable is basically showing us the position and not the index. Hence we have to do some compensation with the index of the array, that is in index of array we need to write I minus 1, and that would make our parallel comparisons. So we are going to check if I is not equals to q of I minus 1. Basically q of I minus 1 means the element that is below it, and we are just going to check if I is not equals to q of I minus 1. Why? Just take a case in which the input would be something like this, that this is the position 1 2 3 4 and I'll just be writing the last two digits 4 and 5, and just think maybe in the position of 4 3 is present, but on the position of 5 is only present. So if 5 is present in the right position, probably he must have not bribed anyone, and or was not bribed by anyone, and he is right now in his right position. So we will not be looking for those cases, and hence we are just looking for those cases in which our I is not equals to q I minus 1. That means our case will definitely run for this fourth index. If there was an input like that, it would definitely work for 4, because at the fourth position there is 3 present. So what we are going to check is, the previous, what we mean by qi minus 2 is the previous element. That means qi minus 2 will definitely point to 3, because I minus 1 definitely is the previous element, and there is one more minus 1 because of the index, so q I minus 2. But before that we need to also do a check, that is I minus 1 greater than equals to 1, because so that we don't get a segmentation fault. Just take for instance I is right now pointing at the first index, so I minus 1 will be 0, and we can I minus 1 will be 0. But the thing over here is, don't get confused at 0 index, it is somewhere pointing in actual sense somewhere even less than 0. So we might get a segmentation error. We are going to that we always see that I should never point anywhere that is less than the 0 or greater than the size of the array, right? So we get a segmentation fault. So just to take care of it, we have first checked, is I minus 1 greater than equals to 1. That means definitely if this condition will actually work at the first index at this position, because it's not going to be greater than equals to 1. I minus 1 will be 0, which is definitely not greater than equals to 1. And that's when we are going to check, is q I minus 2 double equals to I. So here we see that q I minus 2 3, no, it's not equal, so probably this if case is not going to work. Now we are going to else if. In else if we are going to check first, of course, again I minus 2, is it greater than equals to 1, so that we don't get a segmentation fault later on. And then we are going to check, is q I minus 3, that is this person, or this we can't call position, this person equals to the position, that is the same 5. Yes, it is. We see that this 5 is definitely equals to this 5. So what we are going to do is, we are going to get this boy or this man or whatever person he is back to his position. But before that, we'll tell the remaining 2 to just left shift, and we'll get him back to his position. That is where the person has bribed and come. We have just got that person, and we are sending him back to his position. And with that, we are also doing bribes plus equals to 2. That means our bribes right now will hold the value of 2. But yeah, that is the case, and I'll be explaining you the thing that is happening over here. In q I minus 3, we are going to store I minus 2, that is now in this position. At the same time, I'll be just telling you what is happening. So now 3 will basically just keep 5 away. 3 will come back to 3. Then what is happening? Q of I minus 2 is equals to Q of I minus 1. That means in this position, that is 4, we are going to get the Q I minus 1. and we are making qi minus 1 equals to I. Now there will be a question in many of you that usually during swap we take a temp variable and we store it because 5 will be hanging right now. No, we have, but that is not the case over here, because the thing is we have just done a thing that is better, that we have checked that qi minus 3 is equals to, just a second, qi minus 3 is equals to I, and that's the reason we needn't store it into a temp variable, rather just make q of I minus 1 equals to I, which is on the other way equals to I minus 3, but not now after swapping. So definitely our qi minus 1 is going to hold the 5 back, and our bribes variable is initialized. Bribes variable is now added plus 2, so from 0 it became plus 2. So clearly our first iteration is done. Now it will come out of this if condition and go back for the second iteration. Now the value of I has come up to 4. Now I is no longer 5, I is 4. Now it is going to check, is 4 equals to 4? Yes. So it is not going to enter this if condition, only directly everything is going to be not executed, and we are just going to the previous element, that is I minus. So now we came to 3. Now again we are checking, is 3 equals to 3? Yes. Again we got the same thing. Again there will be nothing. Again we will be going for the next value. I minus will bring us to 2. For 2 we are checking, is 2 equals to I, means 2 is not equals to I, so we'll be entering this if loop. Now we are going to check, is the I minus 1 just for the segmentation, the same thing, I minus 1, we are just checking, is there going to be any segmentation error, and we find that no, there isn't, because I is 2 and I minus 1 is going to be 1, and 1 is greater than equals to 1. So we are going to check, is qi minus 2 equals to I? Yes, this 2 is equals to I. So we are just doing a normal swap again without a temp variable, just the way I explained you before. We are first going to make, at the same time I'm just going to explain you that qi minus 2 is equals to I minus 1. That means this place will now hold the value of q of I minus 1. Okay, and q of I minus 1 is going to hold the value of I, and what is I? I is of course equals to q of I minus 2. That means now the position 2 is just going to hold the value of 2 again. And of course the most important thing to do is to update the value of bribes. So there is a bribes plus plus, and hence now the value of our bribes becomes 3. And then we are just going for, there will be one more iteration up till 1, that will be checking with the position of 1. And yes, once that's done, we are just coming down and we are checking, is flag equals to 0? That means, did our flag value change in between, or is there any too chaotic case? No, we find that the flag is still 0. Hence we will be see out, since this is a void function, we are just going to see out directly. We are going to see out the number of bribes that has taken place. Just to do an additional part over here, I'll be even explaining the second case, that is 25134. Just analyze the same condition that was over here. It will start with 4, and it will find that 5, that is the position over here, I, is not equals to this 4. So it will check the qi minus 1, qi minus 2, and this 3 is also not matching. Then it will check qi minus 3, when that is not going to match. Hence what it will do is it will enter this else condition, and else will make the flag value 1, and it will instantly break the loop, because we are not going to check anything else. If there is even a single position which has swapped more than 2 positions to come forward, then directly we are going to mark the case as too chaotic, and hence it will come out of the loop. It will check flag double equals to 0. No, it will enter the else condition to print too chaotic. So this was exactly what I have worked upon, and as you can see over here, the complexity of this solution is probably just O of n, and it will definitely be a better solution than running 2 loops. The first one for iterating through the entire elements, and the second one for swapping basically to the position. So I think that would be quite complex, and this is better than that. So this was my solution. I'm quite sure that you people must have also have some idea or had some idea and already worked upon and must have developed a solution. So if you find this solution good and better, do hit the like button and support my work. Also do subscribe my channel, and I would also request you to share this with your friends who are stuck with this problem or are looking for a better complexity to solve this problem. And definitely always I'm open to learn, and I always tell this in all of my videos that if you got a better solution or if you have any suggestions that you want to give to me, I'm always open. You can just write it down in the comment section below. And also if you want me to make a video for some specific question, please let me know in the comment section below. That was all with this video, and let me just do the final thing that I always do in all of the questions, that is run the code and then submit the code in order to just there's a compilation here. Let me check. Okay, and just a moment. Yeah, and I've been working upon multiple codes for now, and that's the reason there was one more code over there which was not commented. And yeah, that was all with this, and you can see all the test cases have passed. So this was all with this video. This was again the New Year chaos problem under the array subsection inside the interview preparation kit. I'll be trying to cover more questions under this interview preparation kit. So I'll be definitely meeting you in the next video. That's all for now. Thank you.